So yesterday we learned and we practiced how to graph inequalities on a two-dimensional plane where we have x's and we have y's. What we're going to do now is we're going to just do some problems where it's a little bit more complicated, where we have to get the y by itself first. So let's start with number 1. Before I can graph this problem, I need to isolate the y. So I'm going to start by subtracting x on both sides. And when I do that, I get negative 2y is greater than or equal to negative 1x. Now, I'm not going to write the plus 0 because it doesn't really matter, and I do think writing in the 1 here really does make a difference. Now I'm going to divide both sides by negative 2, which means y is less than or equal to positive 1/2 x. Now, a couple things happened here. First, the inequality symbol flipped over because I divided by a negative. The second was the negative 1 and the negative 2 make a positive 1/2. That means that my graph is going to begin on the 0. There's an invisible 0 here at the end. From there, I'm going to go up 1 over 2, up 1 over 2, up 1 over 2. I could also go down 1 left 2, down 1 left 2, down 1 left 2, down 1 left 2. Now I need to decide, should I use a solid line or a dotted line? I'm going to use a solid line because I do have an equal to symbol, which basically just means I'm going to draw a normal line. Last, I need to decide to shade above or below the line. I'm going to shade below because there's a less than symbol. So in other words, below the mountain, below the hill, below the ramp, however you want to think about it, underneath would be this part of the graph. Let's try another one. So problem number 2, again, we would have to get y by itself. So we would subtract x on both sides, and we would get 4y is less than negative x minus 8. Then we would divide everything by 4. Now this time I didn't divide by a negative number, so the symbol stays the same. The invisible number by the x would be a negative 1, so I would have negative 1/4 x, and 8 divided by 4 would be minus 2. Now I'm going to begin on the negative 2, down 1, right 4, down 1, right 4, up 1, left 4, up 1, left 4. I'm going to make this a dotted line, and the reason I'm making this a dotted line is because there is no equal to here. So in other words, I'm going to line up my straight edge just like normal, but when I draw the line, I'm just going to make spaces in it. Now I'm going to shade below, and the reason I'm going to shade below is because it's a less than. So below the mountain, below the hill, just downstairs basically. All right, let's try a couple more. So problem number 3, the first thing we would do is get y by itself. So I'm going to subtract the x on both sides, which means I get 3y is greater than or equal to negative x minus 1. Then I would divide everything by 3. So I would get y is greater than or equal to negative 1/3 x minus 1/3. I'm actually not going to have you graph this one because this is a super ugly number right here. So let's do this. Just to make it graphable so it's a little bit easier, let's go back to the original problem and change this to a negative 3, which would change this to a negative 3, which would just make this a negative 1. That's just going to make it friendlier to graph. Don't worry about trying to do y-intercepts that are decimals. We're not going to be too concerned about that. So we're going to start at the negative 1, and we're going to go down 1, right 3, down 1, right 3, up 1, left 3, up 1, left 3. Now I'm going to use a solid line here, and the reason that I'm using a solid line is because it is equal to, if I look at the inequality symbol. Now I'm also going to shade above. And the reason I'm shading above is because it's a greater than or equal to symbol. So greater means shade above. So upstairs, above the wall, above the ramp, whatever you want to think about it, you just got to be shading that part of the graph. All right, number 4, again, we have to get y by itself. So I'm going to add x on both sides, which means y is greater than x plus 6. we're going to begin on the 6, and from there go up 1, over 1, up 1, over 1, or down 1, left 1, down 1, left 1, down 1, left 1. Now I'm going to go ahead and make this a dotted line. And the reason I'm making this a dotted line is because there is no equal to symbol. And I'm going to shade above this line because I have to be a greater than, so above the graph, which would be this region right here. I'm hoping this helps give some clarity to problems where we have to isolate the y, but let's throw another little twist in here. I don't know if you remember, but we've learned about something earlier this year called Vuxhoy. In the word Vuxhoy, it helped us remember about what are called vertical and horizontal lines. The V stands for vertical. The U stands for an undefined slope. And the X stands for X equals a number in the equation. The H stands for horizontal lines. The O stands for a zero slope. And the Y stands for a Y equals a number in the equation. When we graph vertical and horizontal lines on a two-dimensional graph, some of the shading and stuff gets a little bit different because these are different types of lines. So let's go through some examples here. The first thing I think in problem 5 is, oh my gosh, there is a Y in the problem. So the line must be horizontal. I'm going to make some notes here so you can kind of follow what I'm thinking. I'm going to make a horizontal line at the number 3. And one other thing that I notice is that it should be a solid horizontal line because this time there is an equal to symbol. So, solid horizontal line. Now it's also a greater than, so I'm going to shade above that line because a greater than means shade above. Let's try a vertical line now. The first thing I notice in example 6 is that there is an X. And X's make vertical lines. So I'm going to make a vertical line, and in this specific example, it needs to be a dotted line because there's no equal to symbol. So I'm going to make a vertical line at the -1, and I'm going to make it dotted. Now normally when we're graphing on a graph like this where there's two-dimensional, we say you either choose to shade above or shade below. But you can't really go above a vertical line. No matter how high up you go, there's still a line up there. You can't really ever get on top of it. So this is the only time we ever think about left and right. In this example, because we can't do above, instead of above or below, we think left or right. Since this is a less than, I'm going to shade to the left. So let's make a little note here. This, when we have vertical lines, is the only time we think left or right when we are shading. Otherwise, we always think about above and below. Let's try a few more examples. For number 7, I'm not going to write everything out this time. I'm just going to talk through it. We know we're going to make a horizontal line. And the reason that I know it's horizontal is because there's a Y in the equation. I also know it's going to be a dotted line because there's no equal to. So I'm going to make a dotted horizontal line. I'm going to choose between either shading above or shading below. In this case, because it's a less than, I'm going to shade below. For number 8, I know it's going to be a vertical line because there's an X in the equation. I also notice it's going to be dotted because there's no equal to symbol. Now this is the only time that instead of thinking above or below, I'm going to need to think left and right. This time we have a greater than symbol, which means we're going to shade to the right. We're going to save examples 9 and 10 in case we need a few more problems to try together tomorrow for some clarity. Thank you guys so much for watching the video and taking really good notes, and I will see you then.